In today's lesson, we're going to be talking about solving equations. So yesterday we talked about simplifying expressions. Today we're going to talk about solving equations. So remember, an equation has an equal sign, whereas an expression doesn't. So an equation is basically like a sentence that is saying that two expressions are equal to each other. Now, when we're solving an equation, our goal is to isolate the variable. What that means is we want our final answer, our final step, should say x equals some number. That's the whole goal of solving an equation. We want to find out what value of x, what number for x would make the equation true. What makes the two expressions equal when we put it in for x. So our goal for solving is to figure out what that value for x is. So in the end, we want it to look like x equals something. Now, one of the main things, the main idea that comes when solving an equation is like what I talked about in the lesson from last week on Thursday, which is that we want to preserve equality. So that means whatever we do, our goal is to get x by itself. Whatever we do to the equation to get x by itself, we have to make sure that the two sides of the equation stay equal. If we do something that makes one side not equal to the other side, then we can't do that. We need to preserve equality, and in order to do that, we use this rule right here. What you do to one side, you must do to the other side. So I gave you guys the example on Thursday with a balance beam, with a scale, that if you add 10 pounds to one side, that's going to tip the scale where the side with 10 pounds is going to go down. So to keep it balanced, you have to add 10 pounds to the other side. So what you do to one side, you have to do to the other side in order to keep the equations equal. Now, when you have an equation, again, like I said before, your goal is to isolate the variable. You want to get x by itself. Now, how do you know what you need to do to both sides in order to get x by itself? Well, that's where using this idea of order of operations comes into play. Essentially, what you're going to be doing is you're going to look at your equation, you're going to look at your variable, and you have to determine what is being done to the variable using order of operations, and your goal is to undo those things to get x by itself. Now, the order that things are done in math, usually we use this acronym PEMDAS. Some of you guys might have learned "Please excuse my dear Aunt Sally" as a way to remember it, a mnemonic. But what it is this. Parentheses. So if there are parentheses in the equation, that's the first thing you do. So that would be parentheses. Anything inside of parentheses you do first. Then you do any exponents, so that would be powers, so it could be a power of 2, power of 3, power of 4, some exponent. Then any multiplication or division. Now, division, this is important to note, division is the same thing as multiplying, it's just written in a different way, because you can think of division as multiplying by a fraction. So multiplication, division, they go together. Okay, you do them in order from left to right. So if multiplying comes first on the left, then you would multiply first. If there's division first on the left, then you would divide first. But it goes in order from left to right for multiplication or division. And then the same thing goes with addition or subtraction. You can think of subtraction as adding a negative. So addition and subtraction go together. You just go left to right. If subtraction comes first left to right, then you do the subtraction first. If addition comes first left to right, then you're doing the addition first. So these two, multiplication, division, and addition and subtraction, you're going in order. So one way you can think about solving equations is by using what's called the shoes and socks principle. So the shoes and socks principle says that when you're putting on your shoes and your socks, first you have to put on your socks and then you have to put on your shoes. Well, if you want to undo that, you want to take them off, you have to go in the opposite order and doing the opposite thing. So instead of putting on, if the last thing I did was put on my shoe, the first thing I have to do to undo that is to take off my shoe and then take off my socks. So it's the same thing when solving an equation. Using the order of operations, you're looking at what's being done to the variable and you want to undo them in the opposite order. Now, to undo something that's being done to a variable in math, we use what's called inverse operations. So inverse operations is what can be used to undo something that is being done. So here's a list of the inverse operations, and they go both ways. So if we have the operation of addition, we have something being added. The inverse of that is subtraction. So if something's being added to our variable, to undo that, we have to subtract it. And the same thing goes the other way. If something is being subtracted, to undo the subtraction, we have to add. If we have the operation of multiplication, if something's being multiplied to our variable, to undo the multiplication, we have to use division, or the other way around. If something is being divided, to undo the division, we have to multiply. And the last one, if something is being squared, okay, and this one's very important, especially for Algebra 2. If something is being squared, so we have an exponent of 2, to undo that, we have to take the square root. So that's using the radical symbol and taking the square root. That undoes something being squared. And the other way around too. If something is being square rooted, to undo the square root, you can square it to undo it. So just like subtracting undoes addition, square root undoes squaring, and squaring undoes square root. Now here are some examples of equations that we can solve. I know this is an equation because we have an equal sign, and on either side of the equal sign we have two expressions. So x plus 5 is an expression, 11 is an expression. So these two expressions are equal. We want to solve for our variable x. We want to figure out what value of x makes this equation true. So we want to undo what is being done to x in order to solve for it. Now this is a very simple one and you may be able to do it in your head, but I want you guys to get used to the process because solving equations is one of the most important things in Algebra 2. Now I want you to try these two examples. I use this chart here so that you could list out what is being done and in what order it's being done, and list out the order that it needs to be undone. So pause the video, try these two examples, and we will go over the solution when you're ready. So for number 1, we have the variable x that we are trying to isolate. This is what we want to get by itself. So we have to look at what is being done to x using the order of operations. So I will write it up here. PEMDAS. Okay. So if we look at this expression where x is, x plus 5, do we have any parentheses? No. Do we have any exponents? No. Is there any multiplication or division being done to x? No. Is there any addition or subtraction? Yes. We have a plus 5 is the only thing that's being done to x. So under my list for done, I have plus 5. And that's all that's being done to x in this problem. So to solve for x, we want to undo what is being done using the shoes and socks principle, going in the opposite order. So only one thing is being done here, so only one thing needs to be undone. So we have a plus 5, so the inverse of addition is subtraction. So to undo it, we have to subtract 5. So in this equation, we're going to subtract 5, and what you do to one side, you have to do to the other side in order to preserve equality. If I subtract 5 from the left, but I don't subtract 5 from the right, now these two expressions are not going to be equal anymore. Now this equation is going to fall apart. So when I subtract 5, that undoes the adding 5, and now x is isolated by itself. And on the right side, I have 11 minus 5, which is 6, and we have solved the equation. For number 2, we have an equation that tells us that the expression 8x minus 3 is equal to the expression 21. So if we look at what is being done to x, this is the variable that we want to solve for, we have to look at what is being done. Do we have any parentheses in the problem? We don't. Do we have any exponents? No. Do we have any multiplication or division? Yes, we do. We have 8x, so we have 8 being multiplied with x. So the first thing that is being done to our variable is we are multiplying by 8. That's the first thing that's being done to x. Based on our order of operations, multiplication division comes first. So the first thing that's being done to x is multiplying by 8. Do we have any addition or subtraction? Yes, we have a minus 3. So that comes next. So the second thing that's being done to x, after it got multiplied by 8, it's subtracting 3. So by the shoes and socks principle, if this is the order that it was done, when we undo, we have to go in the opposite order. So if the last thing that was done is -3 or -3, that's like putting on your shoes. The first thing you have to undo is to undo the subtracting 3. So the inverse of subtraction is addition. So we're going to have a +3 is the first thing we're going to do. And the second thing we're going to do, we have to undo the multiplying by 8. The inverse of multiplication is division. So we're going to divide by 8. Second. So let's go ahead and do that. Now, as you do more and more of these problems, using this chart here is going to become less necessary because you're going to get used to the process. So we want to undo the subtracting 3 first. So we do that by doing the inverse, which is adding 3. What you do to one side, you have to do to the other side. Now, adding 3 undoes the subtracting 3, so it cancels out. And we're left with 8x on the left. That's all that's left over. And on the right, we have 21 plus 3, which is 24. Now we have to go to the next step, which is dividing by 8 to undo the multiplication by 8. So I'm going to divide by 8. What I do to one side, I have to do to the other side. If I only divide by 8 on one side, then I'm not going to preserve equality. I have to do it to both sides to preserve equality. Dividing by 8 undoes the multiplication by 8. So now my x is by itself, which is my goal. And 24 divided by 8 is 3. So I get the solution, x equals 3. 3 is the number that when I plug it in for x, it makes this equation true. Any other number other than 3 would make this equation false. So here's another example. So try this one on your own. Now this one's a little bit different because of the way that it's set up. So we're going to talk about the differences when we go over the solution. But I want you to try it first, see if you can find the answer. And then pause the video if you need the time to work on it. And when you're ready, press play and we'll go over the solution. So in this problem, you may notice that the x is coming after the 5. Now, my recommendation, it's possible to solve this one how it is, but my recommendation is going back to the lesson from yesterday about simplifying expressions, is when you have an equation, we have an expression on the left, 5 minus x, and we have an expression on the right, which is 15. The best practice, a good idea to start all of these problems, is to put it in simplest form. Now, if you remember from yesterday's lesson, one of the things that we said that you can do to simplify an expression is to put it, to rearrange the terms in decreasing order by exponent, where the highest exponent's on the left and the constants are all the way to the right. So in this problem, we have a constant, which is 5, and then we have a variable with an exponent of 1. Remember, if nothing's written there, it has an exponent of 1. So if this is not in simplest form because it's not in decreasing order. So we can rearrange this expression where we put our x first. Now it's a minus x, so we have to keep the negative. So this goes back to what we did yesterday. And then we want our constants last. So we have a plus 5. And the right side, just 15, that comes down. There's nothing else that can be simplified there. Now, if you look at it in this form, maybe your answer for this equation is going to be a little bit different now. Or maybe the way that you solve it is going to be different now. Because now you can see that we have x is being multiplied by -1. Remember, if there's no number in the coefficient, you can imagine like there's a 1 there. So this is x being multiplied by -1 and then adding 5. So to undo that, we have to undo the addition first by using the inverse, by subtracting 5. And we would get -x equals 10. And now we want to undo the multiplication by -1 by dividing by -1. So if we divide both sides by -1, Dividing by -1, all it does is flip the sign. So a negative x becomes a positive x, and a positive 10 becomes a negative 10. And that would be the solution. So the best practice is when you have an expression, when you have an equation, make sure both expressions are in simplest form first, so that way it's a little bit easier to see the order that things are being done. Here's another example. Remember what we just did in the last example about simplifying the expressions first, and try to solve for x in this one. So press pause, and when you're ready, we'll go over the solution. So in this problem, we have an expression on the left, which is this entire thing here. 5 times the quantity, so in parentheses, 2x plus 4, minus 8 equals 32. Now, this expression here, and we have an expression here, which is 32. Is this expression on the left in the simplest form, based on the lesson from yesterday? It's not. We have some parentheses, and we have some like terms that we can combine. So to get rid of the parentheses, like the lesson from yesterday, we can use the distributive property by distributing the number on the outside to each of the terms on the inside. So if we multiplied our 5 to each of these two terms, that will get rid of the parentheses and we'll get closer to simplest form. So 5 times 2x, when you have a number with a variable, you just multiply the coefficients. So 5 times 2 is 10. You get 10x. Okay, you got to bring the x with it as well. 5 times 4 is 20. And then we still have this minus 8, and we still have equals 32. So we got rid of the parentheses by distributing. Now this still is not in the simplest form because we have some like terms. We have two constants, a plus 20 and a minus 8. We can combine like terms to simplify it even further. So we would get 10x, 20 minus 8 is a positive 12. So we would get down to this equation, and now it's in simplest form, 10x plus 12 equals 32, and now we can solve it the way that we have been. So what is being done to x? Well, it's being multiplied by 10, and then we're adding 12. So shoes and socks principle, we have to undo those in the other order. So the last thing that's being done is adding 12, so the first thing to undo is to subtract 12. That gets rid of the 12 on the left, and we get 10x equals 32 minus 12, which is 20. And now we just undo the multiplying by 10. To undo multiplication, we have to divide. That gets rid of the multiplying by 10. Now x is by itself, and 20 divided by 10 is 2. So our solution to this equation is x equals 2. So that means if we put 2 in for x, so 2 times 2 is 4, 4 plus 4 is 8, 8 times 5 is 40, and 40 minus 8 equals 32. So that means 2 is a solution. It makes the equation true. So the next type of examples that we're going to look at are going to be examples where you have more than one x in the problem. So you might have an x on either side of the equal sign. Now, one thing that's very, very important to understand, that I've seen a lot of people make this mistake. If you have two x's on the same side of the equal sign, that they're part of an expression, and we can combine like terms like we did in yesterday's lesson. We can simplify the expression by combining like terms. If they're on opposite sides of the equations, that means we have to solve the equation, and we want to use inverse operations. So it's very, very important that you understand this concept. If they're on the same side of the equal sign, you're simplifying an expression, you combine like terms. If they're on opposite sides, you're solving an equation, you use inverse operations. So here's another example. If you want to try it before I go over the solution, go ahead and pause the video. And after, you can press play when you're ready to see the solution. So in this problem, we have two x's in the problem. We have 3x plus 4, this expression on the left side of the equal sign. And on the right side of the equal sign, we have the expression 2x minus 8. Now, when we solve, we need to get the x's together because we want our answer to look like x on one side equals something on the other side, some number. So we want to get our x's together, so we have to put them on the same side of the equal sign, which means we have to move one of these two x's, either the 3x or the 2x, we have to move it to the other side of the equation. And the only way you can move things from one side to the other is by using inverse operations. Now, keep this in mind that it does not matter which direction you go. You can move the 3x to the right, or you can move the 2x to the left. The best practice is to always move the smaller x, so the 2x is smaller than 3x. That way you stay positive. So in this example, I'm going to move the 2x. Now, since this is a positive 2x, the opposite, the inverse of adding or positive would be to subtract. So I'm going to subtract 2x from both sides. What I do to one side, I have to do to the other. That undoes the 2x on the right. 3x minus 2x is just 1x or just x. You don't have to write the 1. So everything else can be brought down. I still have the plus 4 here, and I still have the negative 8 here. So now, this is just like the examples from before. All we need to do is undo what is being done to x. Only one thing is being done here, which is adding 4. So we have to undo that, and to undo addition, we need to use the inverse of addition, which is subtraction. So I'm going to subtract 4 from both sides. That undoes the plus 4. I have x by itself, which is my goal. And negative 8 minus 4 is negative 12. And there's my solution. So here's the last example that we're going to go over. If you want to try it, go ahead and pause the video and press play when you're ready to go over it. And I will go over the solution. So the first thing you may notice when you look at this is that this expression on the left side of the equation is not in simplest form because the variables are not in decreasing order by their exponents. So I can rearrange the terms of this expression to put it in simplest form. I want my variable to come first and then my constant to come next. So I'm going to move the negative 7x, got to keep the negative with it. That's going to come first. And then my constant's going to come second. So since it's a positive 14, I'm going to have a plus 14. So I'm just rearranging the terms to put it in simplest form. And on the other side is already in simplest form, so I'm just going to bring it down. So now, the next step I want to do, since I have an x on both sides of the equal sign, I want to get them together on one side so that I can solve for x. Now remember, in the last example I said that the best practice is to move the smaller x. Now it's important to understand that negative numbers are considered smaller than positive numbers. So in this case, negative 7 is smaller than positive 3 by its value. Okay, so that's something to understand in math, that negative numbers are considered smaller than positive numbers. So I still want to move the smaller x, so I want to move the negative 7x to the other side. That way I stay with positive coefficients. Now in order to move this to the other side, since this is a negative 7x, I have to do the inverse, which would be to add 7x. What I do to one side, I have to do to the other side. That undoes this negative 7x. So on the left side of the equal sign, I'm just left with 14. And on the right side of the equal sign, I have 3x plus 7x, which is 10x, and I have a plus 4. So now you can see we're trying to solve for x. We can see what's being done to x and what we need to undo. So what's being done to x is it's being multiplied by 10, and then it's being added by 4. So the shoes and socks principle tells us that we have to undo it in the opposite order. So we have to undo the adding 4 first. So to undo addition, we subtract. And what you do to one side, you have to do to the other. So that's going to undo this plus 4. 14 minus 4 is 10. And we're still left with 10x. So now we want to undo the multiplication by 10. So to undo multiplication, we need to divide. So I'm going to divide both sides by 10. That undoes multiplication by 10. I'm left with x by itself. And 10 divided by 10 is 1. Okay, and it doesn't matter that x is on the right here and then I wrote it on the left here. You can always switch the order. Like I could have done that in this step. I could have put 10x plus 4 on the left and 14 on the right. You can do that at any step. You can switch the order of the equal signs.